Ladies and gentlemen, this series will probably be the best series for you to watch if you are interested in the metaverse, how to build with 3D in the browser, as well as using the latest technologies. Hey, how's it going guys? My name's Daniel, aka HashLips, and like I mentioned, the purpose of this whole series is to show you a path that you can follow to get yourself more versed with 3D development in the browser. Not only will you learn how to use Three.js and React 3 Fiber, but you will also get to learn how to use blockchain technologies such as Hardhat and Ethereum smart contracts using Solidity so that we can set up a dApp at the end of the day. There is a lot to learn, so this will be an extensive series, but if you follow it step by step, I promise you that you will become a master in understanding the underlying technologies and how to work with them. Another good reason why I'm making this series is because I am involved with the Edenlands Metaverse project, and everything I learn over there, I would love to translate to you. Lastly, before we start, if you ever get stuck with any of my video content, go to the HashLips.online website and join the Discord server. There are thousands of devs that's willing to help you out. Now that I've talked everyone's ears off, I hope you are ready to start coding. I would just like to say that if you really value the content that I make on this channel, please give me a thumbs up, consider subscribing, and leave me a comment below what you think about the series. It really helps me out, and I just absolutely appreciate that. Thank you so much, and let's get going. As always, make sure that you have Node.js installed. So go ahead and download this for your operating system and install it. As for an IDE, you can choose whichever one you prefer. I love using Visual Studio Code, so if you want to follow along exactly, install Visual Studio Code for your operating system as well. Now is the time that we can set up our development environment. Keep in mind that we want to make use of Three.js to give us that 3D functionality in the browser. We are going to do this with the help of React 3 Fiber. This is a wonderful library that basically componentizes Three.js to make it easier for us as React developers to make use of it. That means that we will make use of React. Now, instead of just setting up a bare React application, maybe starting it with Create React App, I want to introduce you to Next.js. Next.js is a wonderful framework that basically sets up React for a very good development experience. It's a product by Vercel, and it seems like this is now the standard these days to set up React environments, and that's why I'm going to be using it here so we keep to modern times. If we look at the documentation and scroll down, we can see it's very easy to use. So let's go ahead and first create a folder that's going to keep all of our applications. On your operating system, wherever you want to save your project, I'm going to just do it here on the desktop, and I'm going to call this React Apps, and there we go. Now that I have this, let's go ahead and open Visual Studio Code and actually open that folder. So there we go, Create React Apps. Then once you're here, go to the top where it says Terminal and click on New Terminal so that you get the terminal at the bottom. If we look at the documentation, we can see that Next gives us a lot of ways to install and set up the React environment. But basically, the best way by far is using create-next-app. Now we are going to try and add TypeScript as well, because that is the best standard to follow when it comes to JavaScript. It is a superset of JavaScript, but it's not that hard to follow along, and I'll just simply explain where the TypeScript areas comes into play. So let's go for the TypeScript option. Copy this line over here. Go to Visual Studio Code and paste it in the terminal. npx create next app, latest, and TypeScript. Put a space and then provide the app's name. For this app, I'm going to call this maybe 3_playground, and then hit enter. Next might ask you if it's okay to install this, and there we go. Now Next is busy creating and setting up our React application. And I will do a whole nother tutorial with Next.js. Currently for this series, we are just going to use it and basically only work with one file, the main index page file. But there's a lot more to Next.js that's very exciting, where you can create dynamic applications as well as static sites. Next is really great, but that is a whole nother series on itself. So for now, let's just wait till this installs. So it's successful, so it means that our React application via Next has now been added. So the next thing I would like to do is reopen this folder over here in Visual Studio Code. The reason is I like personally to be in the root directory, so it's easier for me to teach people what to do. And just a quick tip, if you ever want to know where you are at in your program in the terminal, you can look at the name on the left side of the command. So let's go ahead and click open, and now we can see our 3_playground. Open that up and just bring up our terminal again. Here we go. Now we can see that we are in this folder. So all the commands that we are going to run, we can just do it in here. What we have so far is a basic Next app, and we need to realize that this has nothing to do with React 3 Fiber so far. Let's look at the folders that we have. First of all, we have these configuration files, and the most important one is the package.json. The package.json file is necessary for any node-based application. It gives us details such as what dependencies it needs, the name, the versions, as well as scripts that we can run. Usually in the development lifecycle, we will use the dev command to spin up a local server and test the application as we build. Then when we're ready for production, we will do a build, and then the server will use the start command. We will run the development script in just a second, but for now, let's look at the rest of the folders. The folders are quite self-explanatory. For instance, the styles folder contains all the CSS styles. You can even use module-based styles as well. You can decide to swap the styles out for something like Tailwind, but for now we will keep to pure CSS. We also have a public folder, and in here you put all the assets that you want the client to have. So basically images, music files, whatever that might be. The pages folder is something very special. With Next, it provides us the ability to have routing within this folder. Now, don't worry too much about this API, as well as the _app.tsx. This comes as examples. Where we are going to be doing most of the coding is in the index.tsx file. This is the root directory of our routing, and we don't need to care about any other routes for now. We also have a node modules folder which contains all the dependencies. But for now, let's just focus on this one file. I don't want to confuse you with the setup of Next.js, but this is good. This means in future videos I can make tutorials about how Next.js works because there's a lot to learn. We are now going to try and run this application in development mode. To do that, what we'll do in the terminal is write npm run dev. Hit enter, and Next will spin up for us a local host on port 3000. Now you can click on command and click on this port, and here it will open the application. And this is the base index file that we see over here. It's important to note that at this point, this has nothing to do with Three.js or React 3 Fiber. This is just the basic development setup for a Next application running React. And if you got to this point using a normal React application, using Create React App, that's perfectly fine as well. The whole purpose is just for us to have a React application that we can now strip out and run 3 Fiber. So now it's time to look at React 3 Fiber as well as how to install it. But before we get there, we need to understand something. And a big question might be that why do we need to use React 3 Fiber if we can just make use of Three.js directly with JavaScript in the browser? And the answer would be you can absolutely do that as well. If you go to the documentation of Three.js, here you can see a normal HTML application and how to instantiate Three.js with JavaScript. In fact, I also have a video right over here on how to build a metaverse where I use pure Three.js. The purpose of this video though is to explain why three fiber exists, as well as to show how scalable you can make an application by using a library like Three Fiber when it comes to working with Three.js. Three Fiber makes it easy for a React developer used to the React ecosystem to incorporate components, as well as make use of state, and it's just a breeze to work with 3D elements. You need to know that it is beneficial to understand Three.js as well as React to participate in this tutorial series. However, I'm trying my best to make this very beginner friendly. Does React 3 Fiber have any limitations? Well, actually no. And the reason for that is because React 3 Fiber simply exposes the underlying classes of Three.js. So, in React 3 Fiber, you would define a mesh like this, and with Three.js, you will instantiate one like this. That is exactly why knowing Three.js very well is beneficial when you use React 3 Fiber. However, we are going to go over this in detail. But right off the bat, we can see with Three.js that we have to instantiate classes, assign them to variables, and then set some properties before we add it to a scene or add it to the renderer and so forth. We will see how this process is simplified by only adding components, and it's going to feel very natural. I am going to use this create a scene in Three.js as an example to compare how easy it is to set up the exact same environment with React 3 Fiber. But now enough talk, and let's go ahead and install React 3 Fiber so we can play around with this. Go to the installation process and let's go and see what we need to do for our application. In the installation step, we can see to install React 3 Fiber, we're going to paste this in our terminal. So let's go back, press Ctrl C to exit the execution, and then I'm going to click on Command K to clear the terminal. Let's paste in and install React 3 Fiber by pasting in this command, npm install 3, and then React 3 Fiber. Next, because we are using TypeScript, what I'm going to do is I'm going to type in npm I to say install -D for development dependencies, and then we're going to say we want the types from 3. And that is just to make sure that we have the type declarations for TypeScript of Three.js. One last step that we need to do because we use Next.js is install this Next Transpile modules. And this is something to do with the underlying Three.js ecosystem modules not compatible. So what we're going to do is paste this in here. You can see that we are saving this as a dev dependency as well. And then we can add these two lines to the next config file. So copy those two lines, go to next config and add them here. Save the file. And then what we're going to do in the terminal, again, we're going to run npm run dev to make sure that we can run the application in development and that everything is still fine. At this point, we can clear whatever is in here and start using React 3 Fiber. So let's go to the documentation and click on adding our first scene just to make sure everything is working. To start off, what we need to do is go back into the index.tsx file. In here, what I am going to do is remove everything in here in the render function. I'm also going to take this out because we don't need that. And if we go back to the documentation, we can see that the first thing that we will need is the canvas. We do not need to worry about the React DOM and adding React to our root element because that Next is already doing for us. So let's go and import our canvas element, and in the return statement, go and put our canvas element over here. We have added the canvas, but it has a red squiggly line, meaning that there's something missing. And what's missing is the children. We have an empty canvas. So let's create an opening and closing tag for our canvas, and in here, let's place in something. If we go to the documentation, we can see we can add a simple mesh by using the mesh tag. Notice that tags here are lowercase when we deal with 3 classes. Now let's go and add this. We need a mesh, and inside of a mesh, each mesh needs a geometry and a material. So let's go ahead and copy this mesh with a box geometry as well as a material. In the canvas, we're going to place this, and for now, we have basically added a box. A mesh is the 3D object with geometry and materials, and that's exactly what we give it. We give it a box geometry, which should create a box, as well as a standard material. If we save the file and go back to the application that's running on localhost, we can see an empty blank space. Technically, the canvas is in here as well as the box, but there's no lighting, so there's no possible way for us to see it. However, if we go back to the documentation, I just want to point out that whatever we have done here is the equivalent of doing all of this basically in Three.js directly. Although we can't see the box yet, we'll get to that in a second, but this is important to understand. With Three.js directly, you have to do all of this. You have to basically set up a scene first, then a camera, then a renderer, then add that renderer to the DOM, then create a mesh, then create a box geometry, a material, and add that mesh to the scene. And then this has to do with an animation loop, which we'll get to. But essentially, we've done all of this just by simply adding our canvas, which contains the scene and camera, adding a mesh with a parent-child relationship, so a mesh has a box geometry and a mesh material. At this point, you can see the benefits of using 3-fiber and how scalable it can be. It makes way more sense to do it this way than creating a mesh and adding a geometry to that mesh and a material and then adding it to the scene. It's just way more understandable in my opinion. Now, you might be thinking that 3-fiber is doing a lot of magic behind the scenes and adding more complex things to make this work. In fact, it is not. It is basically a representation of all the 3 classes, like I said. Here we have a mesh, and it refers to the mesh class, and this is how we use it. We have a box geometry, and this is how we reference it. By now, I hope you get the picture and actually start understanding that you can use all the underlying Three.js components and classes in 3-fiber. In fact, you can also use raw Three.js and it will also work by mixing it and componentizing them. If we go down, we can see that all the components, so such as the box geometry one, if you instantiate it, you can provide it some positions and you can add some extra arguments to it. In Fiber, it's exactly the same. You just provide the arguments like so in the component itself. Later on in the series, we will take a look at that in more detail. But for now, let's go and add an ambient light as well as a directional light. So I'm going to copy this, go back to my code, and here in the canvas at the top, add an ambient light, which has an intensity of 0.1, as well as a directional light with a color red and a position that's offset so we can actually see it from an angle. If we save this and go back to our application, we can finally see the cube. Now this is in fact a 3D cube. We can just see it from one angle because it's not animating, the camera is not moving, we're just observing it. And it looks red, and that's because of the directional light shining on it, and it has a red color. Now, you notice that it's very squashed here at the top, and that is because the canvas will actually take up the full width and height of its parent container. So what we can do is maybe create a div and wrap everything in here with the div, and we can give it a class name and call it our container. Save this. Go to our styles, and we can just close the node module. So go to the styles, and in here, what I actually want to do is remove everything there, paste our container, We can give it a width of 100% and a height of 100 vertical height. When we save this and go back to our application, we can now see the cube is right in front of us. Like I said, it is a 3D cube, not a just blank flat square. We will see that now when we animate it, but essentially it's full screen and working. So before we move on to animation, let's quickly look at what happens if we wanted this box to be a bit bigger. Now, if I press Command and click on this object over here, we can hover over the type and see that over here we actually get a few different properties that we get to set. But on the box object itself, we know that we can pass it some arguments. So we can type in the args and give it an array. We can make the box a bit bigger, so let's pass in 2 for width, height, and depth. If we save this and go back, we can see that we get a bigger cube. We can also achieve the same result by, instead of putting this in the constructor of the box geometry, we can set a scale property on the mesh itself. Let's scale this mesh. Okay, wow, we have a very big cube. So maybe a better number would be 0.5, because this works with the whole scale. And if we go back, we can see there's our cube. Now you might ask, which one is better to use, args or scale? Well, in the arguments, it all depends. Every time you change the arguments, it has to reconstruct the object. But if you use scale, it takes the existing object and simply increases it or decreases it. So using scale in this case is a little bit better for performance. Let's now briefly go to the documentation and go down to where we see the basic animation. I want to do this, and the reason for this is because I want to show you that we actually have a 3D cube and not just a simple plane. How animations work in general is the change of position, rotation, and scale over time. Now, how do we get this timeline, so to speak, or this continuous rendering loop? Well, under the hood, the canvas element from 3Fiber gives us this loop, and we can access it using the hook use frame. But it's important to note that you can only ever use these hooks inside of the canvas element. Let's see how this works. So I'm going to be using the use frame, so I'll copy that and paste it here at the top. Then before we return, I'm going to actually make some space and use the frame hook here. Let's give it a function. And then inside here, I'm going to console.log hi. And when we look at the application, we can see that there is an error. Hooks can only be used within the canvas component. And this is exactly what the documentation was talking about. So what this means is we need to go back to the code and create a new component. Let's create a new component, and here we can call it animated box. And this is going to be equal to a function. And in here now, this is where we can use the use frame, but also have a return. And this is normal React code. And what are we going to return? Well, we can return this mesh. So let's cut this out here and paste the return statement, because we want to return an animated cube. And now what we can do is reuse this component down here. So we can say, place our animated box in here. And this is the component that it will render in this line 24. Save this and go back to the application. Right-click and inspect the page. When we go to the console, we can see hi being logged out every single rendering frame. Now, this is great. We know that our rendering loop over here gets executed on each frame, but nothing is animating yet. To finally animate the cube, we need to reference the cube first and then change properties on it in our render loop. We can use the useRef that React provides. So the useRef hook, we can instantiate it like so. So let's create a new variable, and this variable is going to be our mesh ref. So maybe let's do mesh ref. That's going to equal the use ref from React over here. In normal JavaScript, we can just close these brackets and pass in a nil value. Then on the mesh itself, we add the reference to the mesh ref. Now this reference will reference this object and we can change properties on it. However, we are using TypeScript. So with TypeScript, what we can do is include the mesh type. This will just help us later on with completion when we work with this reference. Now we can actually make use of the mesh reference. With a reference, we have to access the current property, and once we do this, we will get access to this object, as well as all the properties. So we can choose the rotation, and let's set the rotation X to maybe itself plus equals to 0.01. And in the application, we can see that we have indeed a spinning cube. Our program is working, but in the editor, we can see this red line. And that is because it's not sure if the reference will be here when it's executing. So what we'll need to do is check if the current reference is indeed here, then only go and try and change the rotation. Now that we have the animated box working, let's gear our project for scalability. So firstly, let's create a new folder and call it components. Then inside of this folder, create a new file and call it animatedbox.tsx. In here, this is where we're going to put this animated box component. So cut it out and paste it in here. We also need to take these references over to the top, as well as export our component. So we're going to export default animated box. Now back in the index file, we can just simply import this. So we can say import the animated box from components animated box. Now that our application is clean and better structured, we can see it's still working as intended with our spinning box. There is one more concept that I would like you to grasp. If you go to the animated box that we have created, we can see that we have our mesh and then the box geometry and mesh standard material. But now, how does these two objects, these two children, know where to attach themselves in the mesh? What I mean by that is if we look at how Three.js does it, it creates a mesh object, and then to this mesh, it attaches a geometry to the geometry property, a new box, as well as the mesh has a material property for a new material. The big question still stands, how do they know? Well, there's a secret property called attach. Now, anything ending with geometry will automatically have this geometry property in the attach field. This means that this box geometry will attach itself to the geometry property of this mesh. To understand this a bit better, if we go to the documentation and click on Objects, Properties and Construct Arguments, here we can see two different ways that you can construct a mesh. From these two examples, we can see that constructing a mesh like this is also possible. We can give the geometry property a geometry. The only reason why this is bad is because if these parameters change, then it needs to reconstruct this whole mesh. That's why we rather wrap these children, a geometry and a material, inside of the mesh. And in the underlying attach property, this is a geometry, and this attach to a material. In this part of the documentation, here we can clearly see that behind the scenes for the mesh basic material, the attach property is material, and geometry for the box geometry. The reason why we don't have to place the attach property in here directly is because it is inferred by the words ending. So anything ending with geometry at the end will get the attached geometry field. That's why we didn't have to specify it. This comes in handy for more complex examples, such as attaching a child to the specific property in the parent. If we wanted to attach this buffer attribute to the buffer geometry's position, in normal Three.js, we had to say geometry, attributes, position. And in here, we're attaching it to the attributes dash position, replacing the dots with a dash. The documentation lays it out quite well, and over here in this example, you can see how you can attach children to parents if they have nested attributes or if they have attributes with arrays. There's a lot that you can learn from this, but if you understand the basic concept that the attached property will attach itself to the parent's property, then you are good to go and will have a breeze coding along with me. We will be making use of this setup as the starting grounds to learn more about the cameras, lights, animations, and a lot of exciting things in the React 3 Fiber and Three.js journey. For those who want to follow along but didn't type with me, there is also a repo containing the starter code in this repo over here. By the end of this series, you will become a React 3 Fiber and Three.js Pro. If you enjoyed this introductory video, hit that like button, comment below, and subscribe for more content like this. I hope to see you in the next video. Cheers for now.